Hello.
Why you are not still joined?
Sir?
You did not join the meeting, huh?
No, sir, join, sir.
Good morning, all.
Good morning, sir.
See, I think we are doing those problems related to M1, D1 equals M2, D2, no?
Yes, sir. Yes, sir.
So here the governing equations is always
M1D1 is equal to M1D1 bar plus M2D2 bar is equal to null bar.
okay. And understood
Understood, sir.
this is what we have studied so far.
Understood, sir. Yes, sir.
Why we take negative sign is
Those both are in opposite directions. M1 and M2 gets displaced in opposite direction.
okay. So
Yes,
solve those equations.
Sir,
Hmm.
sir, if they move both horizontally and vertically, sir, we should take both m into d1 plus d2, sir.
What are you
M into
talking?
d1x plus d2. We have to take like that.
What are you talking? I didn't understand. Tell.
No, sir. If some particles moves vertically and horizontally, sir,
Uh,
like that wedge problem. So we have
uh,
to take m1 into d1x plus d2x.
what
d1x.
D2X? What are D1X? I didn't understand.
No, sir.
Then you will use this one, man.
Yes,
Wedge
sir.
problem, you don't have y displacement for wedge. This need not be used now. I have written
Yes, sir.
here, user main both have displacement vertically. In yesterday's problem, remember that this is having only vertical displacement. This is having both horizontal and vertical. This is having only horizontal, no? That is the reason why we did not use this.
Yes, sir.
And clearly I'm writing, if both have only you use this. In yesterday's problem, that wedge problem, you don't have vertical displacement for wedge. That is the reason why we did not use this. Understood this?
Yes, sir.
Yes, sir.
Frame the equations according to the need. Just because there are equations, no need to frame the equations, no.
No need, sir.
Telling the methods. Completed?
So
Yes,
one
sir.
minute. Sir, 1 minute. Completed, sir.
See, in case of that wedge, let us analyze this. First, suppose if you take this fellow is M1, Planck is M2. When the person comes over here, now you can see this fellow moves like this fellow. Is there any y displacement?
No, sir.
And you have d1x plus d2x relative displacement, no?
Yes, sir.
Because you have only x displacement, we'll use that, that's all. Solve this. In yesterday's problem, this object comes over here. So if this is the case, now you can see for the object to come over here.
Vertically displaced and horizontally also.
However, this has only the vertical. This is moving only from here to here now.
Yes, sir.
So this is having only, this is M2 if I take,
M1.
this is only D2X. Whereas this is having D1Y and D1X. Now both have only Common. Okay, which displacement is common for both? Horizontal displacement. That is the reason why again you use the same thing. And relative to second one, this displacement, this distance it has moved, no base value.
Yes, sir. D2x.
In yesterday's, this is given, this is nothing at h cot theta something you got, no?
H cot theta. H cot
Yes, sir.
theta.
Now you have solved this. This is what you have done. Okay?
Yes, sir.
Not on this.
Yes, sir.
Clear?
Clear, sir.
Yes, sir.
Completed?
1 minute, sir.
Completed?
Yes, sir. Completed.
Yes, sir. Completed, sir.
See, here, so Planck, the person, okay,
Yes, sir.
See here, recoil velocity means the velocity in the opposite direction with respect to ground. Okay.
Yes.
Now suppose now you have velocity of man. Okay, with respect to the platform is, do you agree with this?
Agree, sir.
This velocity is given as VR in the problem.
Yes, sir. Given.
This is man with respect to ground, this is platform with respect to ground.
Yes, sir.
So man with respect to ground is
VR minus V. I can.
understood this?
Yeah,
Now
understood.
is there any external force?
No external force, sir.
Now observe this system, there is no external force now.
Yes, sir. No external force, sir.
Therefore what is conserved?
Uh,
Linear momentum of system is conserved.
Thanks.
So before man starting, initially both are at rest now.
Yes, sir. Both are at rest.
Now when the man walks, what is the final momentum? M1 into
VR
man's
minus
velocity. This is with respect to ground I am conserving.
VR minus VR minus V I can.
Plus flank 1 is V minus I cap now. Now conserving momentum with respect to ground. You have initial momentum equals final momentum. Okay, this is 0. So this gives you what?
Sir, can you move the page a little upwards, sir?
Find out V.
Okay.
Yes, sir.
Understood this? He is asking that one or no?
Yes, sir. Is asking the solution.
So can you once tell the previous page? Please?
1 second. Wait. Let them complete.
So that is VM minus VP, right?
Huh?
In the first line, sir, VMP, velocity of man with respect to platform is equal to velocity of man with minus velocity of platform. No, sir.
Yes.
Not MP, no.
Pardon?
Not MP there, sir.
Platform.
It will be V, na, sir. Yes, sir, thank you, sir.
See, if I give a bar, still it is a vector. Otherwise, I should write like magnitude and direction. Either I should mention in terms of ijk and magnitude, or I should give magnitude and we should specify the direction. Whenever a vector is written as a bar, that means still we did not specify its magnitude and direction. Or we should then, if you know the magnitude and direction, you can specify. Initially, I don't know the magnitude and direction of this. After write this equation, now this is the magnitude of Vm and this is the direction. Understood this?
Understood, sir.
Shall I turn this?
Sir, 1 minute. Sir.
Understood this?
Yes, sir. Understood, sir. So I'm getting V is equal to M1 by M1 plus M2 into VR. Oh.
Pardon?
Sir, M1 VR by M1 plus M2.
Hmm. Shall I turn this?
Yes, sir. Okay.
Shall I turn this?
Yes, sir. Completed.
Forward this?
Followed, sir.
So you have, how much you got? M1
M1 VR by
VR by,
M1 plus M2.
understood this?
Understood, sir.
Right. This some boy asked this one. Anybody asked for this?
Yes, sir.
This one, huh?
Yes, sir.
Previous page only, no?
Yes, sir.
Right. Completed? Just take a
Yes, sir.
screenshot. Shall I turn?
Yes, sir.
Yesterday I already read the exam, man. Okay, fine.
So 1 minute, sir. Previous test.
Yesterday's exam also you felt difficult. Huh?
No, sir. It was easy. Finish, sir.
Right. See, what he means is, so this is the barrel of the gun. What he says is the bullet will come like this. This is velocity of bullet with respect of what?
With respect to gun. Barrel of gun means with respect to
Gun on. Gun on. This is 60 degrees. Okay. Now you can see that this total thing is m. This can move only in this direction now. So let this be having minus I. This is velocity of gun with respect to ground. Okay. Now this is relative velocity. VR cos 60. This is VR sin 60. Now we want the velocity of bullet with respect to gun, ground. Velocity of bullet
with respect to gun.
Okay, now you know that bullet with respect to gun is velocity of bullet with respect to gun minus
It is minus velocity of gun with respect to ground.
see here G means ground. Capital G means gun. B is bullet. Okay, follow this.
Followed.
So now this is VB of gun. We need to know this is given bullet with respect to gun is understood this.
Understood.
Bullet with respect to ground is not known. Gun with respect to this. Agreed?
Yes, sir.
Yes, sir.
Do you agree till here? Any doubt is there?
No doubt, sir.
No doubt, sir.
Correct, sir.
Now we can conserve momentum for gun plus bullet system. Is there any external force?
No,
See,
sir.
this is all horizontal surface, no? So
Yes,
there is no
external force applied.
momentum along x direction is constant, no? Initial momentum is 0 because both are at rest. Final momentum along x direction is mass of this bullet. He gave a mass, right? Mass of bullet, velocity of bullet in the x direction. Okay, plus mass of gun, velocity of gun with respect to ground in which direction? X direction.
Yes, yes, sir.
Do you agree with this or not? Clear?
Yes, sir.
Yes, sir.
We will just write like this. This is M. This is VR cos 60 minus V I cap plus M into V into minus I cap. Now P initial equals P final. Yes, this is 0. Equate this. Understood this?
Understood, sir.
So now when you are doing this problem, one sign goes somewhere wrong. Okay? Or any of these small simple things with respect to ground, instead of that you're taking with respect to gun, whole problem will go wrong, you won't get the answer and get worry starts. That is why physics is difficult, nothing else. You should have a lot of self-control what you are doing. Because physics, the effects will be reflected at the end of the problem. When you do one page fully, finally, you won't get the answer. You will get V. See how much you are getting. Yesterday's paper, anybody got 80 plus? This is a very simple questions I gave, just for first exam. No 80 marks, huh?
I got, sir, above 80.
Very good. Shall I turn this?
1 minute, sir.
Shall I turn?
Yes, sir, complete.
Next. Hold on this. Shell fired vertical up when it reaches the highest point, explodes. Understood this?
Yes.
Understood, sir.
written.
Yes, sir.
Yes, sir, completed.
Now here, at the highest point, what is the velocity of the shell?
0.
Not for all, only for vertically projected. In projectile models, it won't be zero. Remember, in projectile
Yes,
motion,
sir.
it will be at highest point, it has u cos theta.
Yes, sir. X component.
Do you agree with this?
Agree, sir.
Great, sir.
Therefore, just before collision, total mass is system is zero, no?
Yes,
Just
sir.
before collision, velocity is zero, no?
Yes, sir. Momentum is conserved.
Then immediately after the collision,
Yes, sir. Clear.
BF is equal to 4 into 3.
mass of here towards north. See, I can take directions now. East,
Yes, sir.
west, north, south. I will take this as I, this as J. Okay?
Yes, sir. 4 into 3 data.
Sir, one doubt, sir.
Tell.
Sir, here there is mg now, sir. Mg force at highest point.
Yes.
How we can take the momentum? Force is not
One
conserved.
second. I'll do it. I am not still conserving. Okay, I'm just finding the momentum. Okay.
Sorry, sir.
B has mass how much? 2.
Two.
Okay.
So 4.5 I cap.
Towards east. I cap, sir.
4.5 I cap.
Okay. Then we don't know about C. C mass is 3. Because we don't know, we'll write like this is a vector. Understood this?
Yes, sir.
If you keep a bar, that means you don't know the magnitude and direction. Otherwise, you should give magnitude and direction. See, remember, external force is change in momentum by time taken. Now you can check like this also. There may be an external force, but see, the explosion takes place during small interval now.
Yes, sir.
Yes, sir. Small interval of time.
So this way also you can interpret. Which is very small now.
Yes, sir. Very small.
Sir, delta P equals zero.
This implies delta T is 0.
Yes.
Therefore, this is almost 0 now.
Almost zero.
So in this case, you can conserve momentum. Okay.
Yes.
That means when change in linear momentum till here you followed.
Yes, sir.
Now I can conserve now. So now I can take that, substitute P and P value and get VC.
Yes, sir.
There is no external force, momentum is conserved. Or the other way, if External force is there, but the duration during which the linear momentum changes is very small. Then also you have initial momentum equals final momentum. Momentum just before the changes occur is equal to momentum immediately after the changes occur.
Yes, sir.
Today onward, Krishnavan, only today, evening 6:30 or daily?
Only
No,
today.
sir.
Only today, sir. Only today.
Because he went outstation, maybe he'll be coming in the afternoon, I think. Okay. Shall I turn this?
One minute, sir. 1 minute.
Yes, sir.
Sir, till here completed, sir. Doing the calculation now.
Pardon?
4 minus I plus 3 minus j.
How much you got?
4 minus I cap plus 3 minus j cap.
Both are minus one, no?
Yes, sir.
Yes, sir.
That means
Outwards direction.
3 minus I means this side. This is 4 minus j.
Yes, sir. Minus 2.
This is east, west, north, south. This is root over, what is this? Remember this?
5.
Sir,
5.
3 square plus 4 square is equal to 5.
So this is, suppose this is theta. What is the tan theta?
Tan 37. So tan 52, sir.
53. So 50 degrees, that means VC is having 50, this is how much? 5, huh?
5
Yes, sir.
meters.
97.
At 53 degrees, south of west, no? This is west, south of west. Understood this? In the options you will be seeing like this, not IJK.
Yes, sir.
Or 37 degrees west of south. Understood how to give the angle?
Understood,
Yes,
sir.
sir.
Understood.
Even if you know till here, if you don't know this, you cannot pick up the option, no?
Yes, sir. We cannot pick up the option.
Read it, sir.
Completed?
Yes, sir.
Completed.
1 minute, sir.
Shall I turn this?
Yes, sir.
Yes, sir.
let's go ahead with next problem. Okay.
Yes, sir.
See, what he says is, do you agree with this? So, what is the velocity of center of mass?
Mass is 0, 0. By M1 plus M2. 0.
Do you agree with this?
Yes, sir.
Is it clear? Now, okay.
Yes,
Yes, sir.
Do you agree with this?
Yes, sir.
Because it is smooth, no external force. Remember that if you consider only M1, there is a spring force.
Yes, sir. Yes,
Only M2, if you consider, there is a spring force.
sir.
Okay, so M1 and M2 move, but the center of mass of the system will not move. Correct or not? You can see that acceleration is there for the first one, spring force by M1. And A2 is nothing but spring force in the opposite direction by M2. Okay, so M1 and M2 will move.
Will not accelerate.
But if you take M1 plus M2 system,
Yes, sir.
what is the total force here? Spring force will be 0, no?
Total
Yes, sir.
0.
FSP minus FST.
0. Therefore, VCM will not move.
Yes, sir. Center of mass will not move.
Will not.
move,
No.
change.
Understood this? Clear or not?
Yes, sir.
Clear.
So individual particles may move, but the center of mass remain constant. That's what I told no. In our body, blood is flowing from one part to the other. That means the fluid particles are moving. But still, we are unable to move. Unless we walk, that means we are exerting a force on the ground. The ground will be giving the reaction for us and we are able to walk. Agreed? Suppose there is no friction between us and the floor, we cannot walk because there is no friction, means no external force causing motion. Clear or not? So here, that is the reason why we have this is finally after they move. Okay, VCM dash must be equal to VCM, no? So you have M1 V1 plus M2 V2 by M1 plus M2 is 0.
0.
That means M1 V1 plus M2 V2 is 0. Do you agree with this?
Yes, sir. M1 equal to
Do you agree with this or not? Vectorially.
Yes, sir. Agree, sir.
yes, sir.
That means initial momentum magnitude.
Final momentum magnitude equal.
So initial momentum equals final momentum.
Yes, sir.
Understood this?
Understood, sir.
Note the means individual particles may be moving, but
Sir.
the center of mass of the system need not move.
Yes, sir.
Shall I turn this?
So 1 minute, sir. 1 minute. Completed, sir.
Shall I turn this?
Yes, sir. Completed.
Now, in this particular problem, if you read this, so for M1 plus the momentum is conserved, no? Initially both are at rest. Finally, they move in opposite directions. Remember this?
Yes, sir. They move in opposite directions. Due to spring force.
Agreed. Suppose if you don't know this, you just keep it like this, no problem. So V1
Minus M2 V2 bar
negative sign
indicates that they move in opposite. M1 and M2 move in opposite directions.
Okay,
Yes, sir.
clear?
Yes.
Magnitude wise, we have this now. So he is asking the ratio of this.
Two by m.
This is one thing. He is asking that one now.
Yes, sir, that only, sir. First, then displacement ratios.
Ratio of velocity means magnitude of velocity. You cannot, this is wrong actually, don't write like this. Why? Because you cannot divide vectors. Only magnitudes can be divided. This is correct. Okay?
Yes, sir.
Never divide vectors.
Yes, sir. Magnitudes of the vector.
Understood this?
Yes, sir.
Yes, sir.
Ratio of acceleration.
Again, you can see can I take the integral like this?
Yes, sir, possible. M1 and M2 are constant.
What is this actually?
It's DS1, DX1, DX2.
X2.
And
Okay, now he has asked the what is asking.
the ratio between displacements. Yes.
Understood this?
Understood. One more is asked, sir. Ratio between
Acceleration.
Okay. See, what is the force on each one?
spring force.
This is spring force now on first block.
Yes, sir.
On the second block, this is spring force now. Now both spring force are same, no?
Same only, sir.
Yes, sir. Only.
Yes.
Magnitude wise.
Yes.
Yes, sir.
So the acceleration of first one, this gives you A1 by A2 is, understood this?
Understood, sir.
Is it clear?
Yes.
Hello?
Clear, sir.
Yes, sir.
Yes, sir.
Shall we go ahead?
Yes, sir.
1 minute, sir.
1 minute, sir.
Shall I turn this?
Yes, sir. Completed, sir.
Hello?
Completed, sir.
Completed, sir.
See, this is one truck. Okay, this mass M, it is moving like this on this track. Now, another truck is moving in this direction now.
Yes, sir.
If there is a bag, this is another bag. Understood this?
Understood, sir.
Clear? See,
Yes, sir.
M includes even that one also.
Mass of bag.
Do you agree till here?
Yes, sir.
See, here in the vertical direction, when they are exchanging this, follow carefully, the bags are being exchanged. Read that. That means they are throwing the bags like this. When the trucks approach nearer or side by side, or when they are crossing each other, now one truck. Okay, so this is moving now. This is one bag that goes into this M2, that is thrown like this, and that bag is thrown into this. Agreed? Understood what I am saying?
Yes, sir. Understood. Yes, sir.
This is M1. That means they exchange the bags. Clear?
Clear,
Yes,
sir.
sir.
Understood this or not?
Yes, sir. Understood.
Now, note down this. Let us discuss this problem.
Yes, sir.
You can see that the bags are thrown like this. Shall I go ahead?
Yes, sir.
Yes, sir.
Now you can see that in the direction. This is the direction perpendicular to the motion of truck, no?
Yes, sir.
Yes, sir. The bags are thrown in perpendicular.
Now, in this direction, we can conserve momentum. Let us see what happens to it. So far followed? Clear?
Follow,
Yes,
sir.
sir.
Clear.
So, horizontally, now when you throw a bag in this direction, you have to apply a force, no?
Yes, sir.
Yes, sir.
Understood this?
Yes, sir.
So, for no force, this you followed?
Sir.
Any doubt is that till here?
Ah,
There
yes,
is
sir.
no force, no?
Ah, sir. Only perpendicular, not in the direction.
That means I can conserve momentum, no?
In the direction of yes, sir.
Agreed? Now let's see. This is truck 1, truck 2. Shall I turn this?
1 minute,
Yes,
sir.
sir.
Yes.
1 minute, sir. Completed.
Completed?
Yes, sir.
Completed, sir.
So here, for truck 1, if you take, initially,
Velocity of
just
truck
see,
one.
this is thrown, truck going in this direction now. So here, this bag, this is having a velocity like this now.
It's the same.
Okay, it is thrown like this. Do you agree with this or not?
Yes,
So
sir.
initially, for the truck, can you tell what is the initial momentum?
Sir, M1.
MNU.
Actually, this is the mu. But in this momentum, this bag is momentum should be removed, no?
Yes, sir.
Agreed?
Yes, sir.
Followed?
Capital M1. Yes, sir. Followed, sir.
Clear?
Clear, sir.
Yes, sir.
Momentum of truck.
Do you have any doubt in this?
No doubt, sir.
Sir, final it will be M2U.
Then I am taking for the bags. See, this initial momentum. Do you agree with this or not?
So that's last one I didn't understand, sir. Minus into.
Yes, sir. Initially the bag.
See, Again, get back to this.
Yes,
This is a truck one. No?
yes, sir. Truck one.
Yes, sir.
This is having U.
Yes, sir.
Now from this you are having one M1U.
M1.
Yes, sir.
Yes, sir.
Another one is having like this M2U. Now this is coming like this is going like this now. I am using conservation of momentum for this setup. Agreed? That means before the bags are still in tail.
Yes, sir.
Yes, sir.
Then what is the momentum? I am taking MU. Okay? Along minus I. Do you agree with this? From that, you have to remove this. Do you agree or not?
Yes, sir.
And you should add this because that is
Coming.
taken over. This side, no? Do you agree till here?
Yes, sir.
Yes, sir.
Any doubt?
No, sir.
Followed?
Yes,
Sir,
sir.
followed.
Now, after bag reaches, what is the momentum? Can you tell? This truck has lost this, gained this. It has lost this and gained this. Do you agree with this? So this is the velocity after exchanging. Any doubt is there in this? You can ask.
No, sir.
No, no.
Now you can conserve this, no?
Yes, sir.
You will get velocity of the first truck after exchange of bags. See how much you are getting. Hello. Followed?
Sir, that V1 is
Follow.
final velocity now, sir.
The final velocity after the bags reach. Understood this?
Yes, sir.
I'm getting M2 plus M1 minus capital M divided by.
Pardon?
I'm getting M2 plus M1 minus capital M divided by M minus M1 plus M2 into V, sir. Into U.
Direction is not there. I, J, nothing.
All I cap, sir. I cap.
What is that you are getting? MU
Plus M1U.
Sir, plus M to U.
Sir, there plus
Sir,
M2U,
plus
sir.
M to U, sir.
where?
M1U
Yes, sir,
plus M2U.
numerator.
Denominator, huh?
No, sir, numerator.
Plus M to U.
M1U plus M2U.
See, if you observe this, both must have same sign, no?
Yes, sir. The
Yes, sir, both are having same sign only, sir. Minus and minus I cap will get cancelled, sir. So we will get plus M1U I cap.
1 second.
Plus and plus. Yes, sir.
This is what you will get.
Yes, sir. I got it.
Yes, sir.
Agreed? The same thing I am writing like this, man.
Minus I.
Understood this?
Yes, sir.
Yes, sir.
Followed?
follow this.
Like that you can do for the second truck now.
Yes, sir. MU.
Try. No, you draw the diagram, and because you should have that what is going on. Physics is not formulas. You should know what is going on in the situation given. The total knowledge of that you should have, and otherwise you cannot. Shall I turn this? Understood the method?
Understood the method.
Shall I turn this?
Yes, sir.
Now the same thing I'll apply for the other truck. What is the other truck situation?
Comes to the truck.
This truck 2, no? Now from this M2 is going away. M1 is coming, no?
Yes, sir.
Yes, sir.
This M2 is having a velocity in this direction, no?
Yes, sir.
Before throwing, this is having velocity in this direction. This is having velocity. So when bags are in air,
MU. They're in A.
this is MU. M1 is removed, no? Agreed? And M2 what you have? The truck continues to move like this. It has lost M2, gained M1. Do you agree?
Agree, sir.
See, be careful. One sign, whole problem will go away.
Yes.
Now tell what is it you are getting. Understood what I am speaking?
Understood, sir.
Velocity
MU I. Hold on.
Are you getting this?
Yes, sir.
Is it clear? Just understand how much effort you have to keep to learn physics. That's why I'm making you to do all this. You'll be knowing. Don't play with physics. Very difficult also. Engineering also is trouble. You don't think IITs and all are secondary. Some in any higher classes, you want to be in the line of physics is very difficult. It needs total dedication, man. Not such an easy one. Colleges, they don't know anything. Geology, botany, chemistry, physics at a time, they ask us to complete. Similarly, physics, maths, and chemistry. Chemistry is theoretical one. Mathematics is purely formula based. No law, nothing is there in that. Why to do like that, we don't know. The problem here is both theory and also why to do, we should know applications. Hello, you got this?
Yes, sir.
Yes, sir.
Clear?
So the previous page one, sir.
Till here, all of you followed?
Follow.
Yes, sir.
Right,
Yes,
then we'll do it in the next class then. Note down this.
Yes, sir.
Hello?
Completed, sir.
Right. Somebody who needs this, Sabra, take the screenshot.
Yes, sir. Yes, sir. Completed.
Right then, we'll meet in the next class.